Welcome to Study Loop.
Okay, so let's draw this problem out because it's a little difficult to understand what the question is asking. So this is our top surface. We have a pendulum that's being pulled at an angle, theta. Okay, and it's going to swing like so. We'll call this positive A. We'll call this negative A. So this is the full amplitudes. And if we look here, this thing will swing. A full period is when it swings down all the way to the other side and then swings back. So it'll reach its maximum speed in a quarter of an amplitude, t over 4. So that's how much time, a quarter of a period. So that's how much time it takes to get to this equilibrium position here, is 1/4 of a period. So we could solve for t over 4. This is just going to be 1/4 times 2 pi square root of L over G. So this is pi over 2 times the length, 0.024 over G, which is 9.8, 0.246 seconds. Now, you see how this didn't depend on the angle theta at all? And that is because it's only dependent on the length of the pendulum and the strength of gravity. So this time will not change if theta changes.